So last time we learned the power property, which is right back here, namely that when you have a logarithm of a value to a power, you can bring that power down in front. And that's going to really help us when we get down here. So, not at first, of course, because the first part is really simple. I was just reminding you of some stuff that you already know. That x plus 2 is equal to 5. And then as a kid, you learn, oh, okay, subtract 2 from both sides. And you're going to get x equals 3. Right? Everybody knows how to solve that. Well, the reason it works is because addition and subtraction are inverses of each other. Right? Let me make that note. So addition and subtraction are inverses. Okay? And that's why you learned that as a kid. Right after you learned adding, you learn takeaways, right? Well, all right, now what about x times, this was 2x equals 5. Well, that's multiplication, right? And everybody learns, right after you learn multiplication, you learn division. So you divide both sides by 2, and you're going to have x equals 5 halves, which is 2.5. I'll just leave it 5 halves, that's fine. Right? Why does that work? Well, because multiplication and division are inverses of each other. Right? Make a note. So multiplication and division are inverses. Right? Okay. Now, those are kind of basic ones. Like you learn those in pre-algebra classes, right? But then we've also picked up on kind of a harder one, which is right here. When x is squared, we learned this in section 4.1 and 4.2. So if you have x squared equal to 5, you'd say, okay, well, to get x by itself, what I'll do is I'll raise both sides to the 1/2 power, or in other words, take the square root of both sides. It's the same thing, remember? So 1/2 power, which is raising this to the 1/2 power, or you could think of it as the root, right? That's another way to think of it. It's the square root of x squared is equal to the square root of 5. Technically, it's plus or minus, but it's not really the point that I'm trying to get at here. But whenever you take the square root of both sides, whenever you take an even root of both sides, you have to do plus or minus. Sorry. There it is. So this or this, either way. And if you use a calculator, you'll find that that's about 2.236 or so. Plus or minus. Okay. So, but the gist of it is that it works this way because you were able to take the root of both sides, right? And that means that squaring, and it's really powers and roots are inverses of each other. Okay? Powers is when you take your variable and raise it to a power. That's called a power function, or a power equation in this case. Now that's different than d, and that's what I wanted to show you. So 2 to the x, you can't do what we just did. You can't do the root because you don't know what root it would be, because your variable is your exponent. So you need a way to be able to get this variable out of there. You ready for it? You take the log of both sides. Now I know what you're thinking. You're thinking, Alana, that is not easier. Well, you'd be right. It doesn't look easier, but it is. Here's why. It is the only way that we know to get this x out of this exponent. Because of the power property back here. Because when you have a logarithm, like this one is, of 2 to the x, you can bring that x down in front. And write x log of 2 equals the log of 5. Like that. Then to get x by itself, well, that's multiplication, so you just divide. Divide both sides by the log of 2, because log of 2 is just some number with a calculator, right? I don't know what it is, but I could make a calculator find it if I had a calculator. Okay? So these will all disappear, right? Log of 2 over log of 2 is 1, right? Whatever the heck that number is, when you divide it away, it's 1. And you get x is equal to the log of 5 over the log of 2. And you just make a computer find this, or a calculator. So I can't show it to you because I don't have a calculator right now, but it should be about 2.3219. I can check it. Let's see, I brought a calculator up here. Okay, so let me try this. Log of 5, right? And then I want all of that. So I'm going to go over to the right. And then I would want that divided by, oopsie, hold on, log of 5. And then I would like that divided by the log of 2. Oops, I pressed the wrong button. Log of 2. There we go. 2.32. Cool. Yeah, sorry I can't show you on the TI-83, but you should be able to do the same thing and get log of 5, close your parentheses, divided by the log of 2. You should be able to get 2.329. And the lesson we've learned here, and we've learned it before, but I'll say it again, exponential and logarithm are inverses of each other. They unravel each other. Math people never like to learn a new operation without learning how to get rid of it. That's just how they are, right? So whenever we create something like adding, we instantly create subtracting to undo it. When we create multiplying, then we know how to divide to undo it. Squaring and roots go together, like powers and roots, like third power, third root would go together. And then now you've learned exponential and logarithms go together. When your variable's in the exponent, that means you have to take the log of both sides. And that's what this says right down here. That's this property, is that, hey, you can totally take the log of both sides. I mean, if you can add something to both sides of an equation or divide both sides of an equation, then you can sure as heck take the log of both sides. As long as you do it to both sides, it's fine. All right, so let's use that to help us solve some more complicated problems. So, oops, hold on. There we go. All right, so we've got 2 times 6 to the x equals 253. Now the kicker here is the order of operations. Remember order of operations? Please excuse my dear Aunt Sally, right? Let me put it up here. Exponents come before multiplication. So the mistake a lot of students make is they'll make 12 out of this. No, 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 no. You cannot do multiplying until you've dealt with your exponent. And you can't deal with your exponent because it's a variable and you don't know what the heck it is. So you're in trouble. What you could do, however, is divide both sides by 2, right? Get the 2 the heck out of there. That's multiplication right now. So divide both sides by 2. You'll get 6 to the x over here equals whatever 253 divided by 2 is. Let me pull up my calculator. So let's see, 253 divided by, oops, clear. 253 divided by 2, 126.5. All right, so that's 126.5. All right, I've got the variable in the exponent. See it right there? There is only one way to get variable out of an exponent, and that is using this property right here, that exponentials and logarithms are inverses of each other. Can't stress it enough. So what we're going to do is we're going to take the log of both sides. So I'm going to take the log of 6 to the x. The x can actually be on the outside of the parentheses. It doesn't really matter. And then 126.5. Then you bring the x down in front. The whole reason for doing it is so that you can bring the x down in front and make it multiply. Then you divide both sides by the log of 6, because whatever the log of 6 is, it's just something number with a calculator, right? Your calculator will find what log of 6 is. And of course, if you do it over there, you have to do it over on the right-hand side to keep it fair. And there you go. So x is, and because this will disappear, right? The log of 6 is gone. And all that leaves you with is x over on the right-hand side. So x equals, and then you just find what the log of 126.5 over the log of 6 is. When I did it with my calculator, I got 2.701. Oop, poof, there it is. Again, log of 126.5 divided by the log of 6 is 2.701. And you should be able to find that with a TI calculator as well. All right, we're done with that. Now let's do it again for the next problem. Let's see what we got down here. Ooh, okay. So we got a couple variables. Now let's remind ourselves of a couple things. Remember, there's a property that involves multiple variables. Let me just put it down here for you. Remember, b to the p times b to the q is equal to b to the p plus q. We learned that in section 4.1. So in 4.1, we learned this. And really, it's not for that question, it's for this one, so I should put it down here. All right, Now, how is that helping us? Well, you have 3 to the x times 3 to the x plus 2, or 3x plus 2, excuse me, equals 341. Oh, I could write this. Okay, so according to that property, what we can do is we can add these. X plus 3x plus 2. You can add those two, equals 341, which means 3 to the 4x plus 2 is equal to 341. So I'm just cleaning it up. I'm trying to make it so it's number to something with a variable equals number. Now I can take the log of both sides. Right? Now you're thinking, well, how would I know to do that? You'd know to do that because your variable's up in the exponent. When your variable's in the exponent, the way to get it out of there is to take the log of both sides, and that will cause that variable exponent, 4x plus 2, to come down in front. Then you have the log of 3 equals the log of 341. All right, you want to solve this sucker for x. So what you want to do is get rid of this timesing by the log of 3. So just divide both sides by the log of 3. That'll be great because that'll cause this to disappear. Here, let me make this bigger. So this will go away. And so will this. Beautiful. But if you do it to the left, you got to do it to the right. Keep it fair. So you put log of 3 over here. So what are you going to be left with? 4x plus 2 equals whatever that number is. So let me find that with a calculator here. So clear. I just Googled this, by the way. All right. So let's see. The log of 341, close my parentheses, divided by the log of 3 equals, or enter on the calculator, 5.3. Oops, 5.308. It's squiggly equals because we've approximated at this point. That's okay. 5.308. And now you just subtract 2 and divide by 4 and you'll be golden, right? So subtract 2, do it over there, you got to do it over here. So you'll have 4x equals 3.308. Divide by 4 to both sides. Oops, there we go, 4. And you'll have x is whatever that number is, 3.308 divided by 4. So let me go grab the calculator. So I'll subtract 2 from that number, and then I want to divide it by 4, 0.827. And we're all set. All right, I think I can fit in the last, this one right here. All right, so for this, we're going to do 5, I'm going to rewrite it. 5 to the 7 equals x to the third, right? I'm rewriting it. It was in exponential, or excuse me, logarithmic form, and I'm going to rewrite it in exponential form. And this is 78125 equals x to the third. This is actually very similar to one we did earlier, so I don't see the big deal here. Now remember, when you want to get x by itself in something like this, you want to take the third root of both sides. So you do 1/3 power over here. Oops, 1/3. And then if I do it to that side, I got to do it to this side. There we go. So now x is equal to whatever that number is. So 78125 to the 1/3, use a calculator. Don't forget to use parentheses around the 1/3, right? And you should get 42.749. All right, we're all done with that. And I'll have to come back for the last video, which needs a calculator. But basically you put one of them in y1 and one of them in y2, and you go from there. But I'll have to show you that in another video. See ya.